There is one mental framework that sits at the center, an idea so important that if you capture it, it can change the way you engineer forever. The agentic layer. This is the new ring around your code base where you teach your agents to operate your application on your behalf as well and even better than you and your team ever could. Focusing on building the agentic layer of your code base is the highest return on investment action for any engineer in the age of agents we live in. Why is that? As you know, when you scale your compute, you scale your impact. We're not just AI coding anymore. Our agents can take actions on our behalf. And this has changed engineering forever. Once you've built a sufficiently powerful agentic layer, something will happen. The Codebase Singularity. In this moment, you, the engineer, will realize one simple fact. My agents can now run my code base better than I can. I trust them to ship more than I trust myself or my team. Nothing ships to production without my teams of agents. Yes, this might sound crazy, it might sound far out, but if you've been pushing what you can do with agents, if you've been putting these tactics to work already, maybe you already see this future on the horizon, the Agentic Horizon. I can tell you this for certain. Right now, there is an agentic layer that could exist inside your code base, so powerful that your code base runs itself. The only question now is, do you know how to build it? As we work through building agentic layers, keep this idea in your mind and think through what it would take for you to trust your agents to run your code base better than you could, from prompt to production. In this lesson, we're going to put together the missing pieces and see how we can attain the Codebase Singularity. There are three concrete classes of the agentic layer: class 1, class 2, and class 3, each defined by a unique element that makes them distinct from the rest. Our whole goal here is to look at the components, the raw elements that make up the new ring around your code base, where you have agents drive your engineering experience and you drive your agents. The green squares here, the outer layer, this is the new agentic layer. The inner layer here, right, these dark squares, this is going to be your application layer. And we're bundling a ton of things underneath your application layer. We're talking about your database, your front end, your back end, your scripts, all the application stuff, even your DevOps stuff, right? This all goes underneath the application layer. Why is that? It's because we want to be able to bundle your different repositories underneath your agentic layer, so that we can do something like this. Code bases often contain more than one application. So by bundling your agentic layer around your applications, your agents can effectively see everything. Every class is going to have 1 to n grades that will give you a rough understanding of how powerful your agentic layer is. You're going to be able to quickly identify where you are as we move through classes and grades so that you can make improvements and get to that next level. And then once you reach the limit of a certain class, look to make that next jump uniquely identified by a new dimension that we'll talk about as we progress from grade to grade, from class to class, all the way up to class 3 and the final grade. Now, let's start by looking at a powerful version of a class 3 agentic system with an orchestrator guiding the workflow. You've seen powerful systems like this in our previous 2 Agentic Horizon lessons. What we're going to do now is run 2 brand new workflows and combine some really big ideas. I'm going to open up the prompt interface here as usual, and you'll notice we have one new section. Our orchestrator agent can now kick off AI developer workflows. I'll paste in this prompt here, and I'm commanding the orchestrator agent to kick off this specific workflow in this specific directory with just a single simple prompt. We're not overcomplicating this. I just want to show you so that you have a concrete vision of the types of systems you can build out. So we're going to fire this off here. Let's go ahead and run another build out a markdown preview application here in one shot with our plan, build, review, and fix. And this is an AI developer workflow. So the orchestrator doesn't need to do anything, right? This runs end to end. We're going to run one more workflow here, and then I want to show you something awesome. You've seen the generic log stream view. We have pushed our orchestrator to be able to control AI developer workflows. We now have 2 workflows running. So plan, build, review, fix, and just a simple plan build. We have given our orchestrator agent the ability to run arbitrary end-to-end workflows. Now let's dial in and start from 0, right? Let's reset, because we don't start here. We don't start at class 3. We don't start with powerful orchestration systems. We start with nothing. So as mentioned, every single code base should now have these 2 key components, the application layer and the agentic layer. These 2 squares here represent a brand new code base. Now, oftentimes you'll be operating in an existing code base that will look like this, right? You'll already have some pieces, right, modules, files of your application layer, and then you'll start adding on your agentic layer around your code base. Now, what does this really look like? Let's start from a greenfield, brand new application, just to make this all clear. What exactly is in our agentic layer? This is our class 1, grade 1 agentic layer, the thinnest possible agentic layer you can have. A small amount of code, and you have a prime prompt and or memory files. It doesn't get thinner than this. If you have this, you technically have an agentic layer. Now let's dive into a concrete code base structure to see what this looks like. This is an example project structure. We're going to work through several of these to make it absolutely clear what it looks like to have an agentic layer surrounding your application layer. All right, so we have application layer files, folders, directories, so on and so forth, and we have our agentic layer files. If we open up .cloud here, .commands, we can see we have this prime command. As you know, the prime command effectively represents a memory file, but the big difference here is that you can activate this whenever you want to, and you can fine tune the prime command to run any specific workflow you want to. Okay, so this is just a prompt that effectively activates your agent to read specific files, right? So there's nothing new here, right? We have a classic agentic prompt. .cloud, of course, is our memory file that's always going to load. You've seen this, you understand this, you know this, and oftentimes I like to take the agents.md if I'm working with other agents and just reference that claude.md memory file. This is the simplest possible agentic layer. Now, in our application layer, if we're going to user management, where we have a backend for a user management system. This is just a starting place, right? This is a great way to, when you're creating a new application, just start with something. An agent can come in here and understand how to operate this right away with the memory file and with the prime command. Okay, so as we work through classes and grades, we'll talk about the compute advantage you get by scaling to this class and grade of agentic layer. And then we'll of course talk about trade-offs. So the compute advantage here is obvious, right? We get a clean, minimal setup. It's a great foundation for agentic growth, and agents understand context immediately. It's a super small code base. This is easily reproducible by anyone. There's no value in a code base this small. It's useless for large code bases. Limited capability, and there are many leverage points of agentic coding that the class 1 grade 1 agentic layer purely misses. Let's scale this up. Now we have the class 1 grade 2. This is where we start surrounding our code base with more useful leverage points of agentic coding. Here we incorporate specialized prompts to help us plan work. We have a prime command, and we now have access to agents, also known as sub-agents. Here we can start incrementally improving what our code base can do. So let's go ahead and look at what this code base looks like now, right? We have a new specs directory where our plans are written. You're very familiar with that pattern. We also have AI docs, so our agents can pull in documentation to aid their context. This is all part of the agentic layer, and our user application is starting to grow. We have a few tests, we have modules, but the most important pieces are here. In addition to our commands, right, our raw prompts, we now have some sub-agents or just some agents that we can run, right? So for instance, you might have a fetch docs sub-agent that will save them in the AI docs directory, and you might have a test writer. These are just simple examples of starting to scale up your agentic layer. You likely have something more powerful than this, but we're just working our way up. And now you might have something like a brand new plan file. So when you're doing work, you might prompt this plan file and then execute it. Very simple. We're still just stacking things up, slowly building up our agentic layer. This is a simple class 1 grade 2 agentic layer. The big advantages here is that we have specialization with sub-agents, and we can scale this and parallelize certain workflows. All right. And now we're starting to collect documentation for our agents, and we're planning our work before we implement. So this is grade 2. Many engineers have passed this level. This is not that novel. It's not that interesting. We're still limited in many ways, right? The big thing we're missing here is custom tools, which brings us right to grade 3. So in class 1, grade 3, things start getting interesting and our agentic layer starts to wrap our application layer. So here we have 3 key new pieces: skills, MCP servers, and prime commands with tool access. You likely already know what that is. All of these 3 things give us the same thing: custom tools that enhance our agent's core 4. Let's take a look at what this actually looks like in an agentic layer. Class 1, grade 3. Now we have a couple additional base level files. You might have a .mcp.json, Postgres, Firecrawl, Jira, Notion, whatever tool you want to use, you can now throw it in here. But that's not all. We know that MCPs are very token heavy, and we can just prompt engineer properly to get our agents the tools they need. One of the ways that that can be done is with skills. Our agents have learned to migrate the database. And so inside of this file, you've seen these before. We have taught our agent how to use a specific tool, and it can now use it to perform a specific task. We're starting to specialize our agents a little bit more outside of our sub agents. But we can also do things like this, right? Start and stop application. If we open up this skill, we are just teaching our agent how to use scripts. There's no need for an MCP server oftentimes. You can just build your own script that exposes the right functionality. Here we have a start and a stop tool that starts and stops the application, okay? So we're just scaling up what our agentic layer can do. We're giving our agents more capability, right? We are scaling our compute to scale our impact. Our agents now have access to custom tools, skills, and prime commands, right? And keep in mind, this is something that I want to keep emphasizing. Skills and MCP servers can both be replaced with just a simple prompt. Okay, so we have this prime DB with tools. You can teach your agents how to execute CLI commands. Here, we're just using PSQL, right? So that our agent knows how to interact with the user management database for this mock application. And so you can bypass everything by just understanding how the core 4 works: context model, prompt, and tools. Okay, and notice what we're doing here, right? We're constantly giving our agents more capability. Custom tools is a huge step. Grade 3 is very important. Now, this is when prompt engineering, context engineering becomes more important. Skills, MCP servers, and prompts must have tools carefully designed. This is where things can start going wrong. And a lot of engineers do get stuck at grade 3. They think they get past this, but actually their tools are terrible and they won't scale, and they're chewing up tokens, they're burning cache, and they're over-engineering their tools, right? Like one of the most common problems is that engineers will have way too many tools. Being able to design and give your agents the right tools via MCP server skills and just raw prompts is a critical skill for every agentic engineer. Let's move on to grade 4. How do we scale this up even further? What comes next, right? So at this point, we start scaling up our prompts and we start building up feedback loops in the code base, okay? So this is where things become very powerful and where you can really scale what you can do. So of course we have our plan prompt, but now we'll have things like our build prompt, right? A higher order prompt. Grade 4 is distinct in that you start asking your agents to review their work. This is where you realize that you should always add feedback loops into your agentic layer. You're effectively adding more compute to get more confidence in your agent's results. All right. This is the big idea in tactical agentic coding, lesson 5, right? Here we're building closed loop prompts. All right. Let's understand the application structure. So now we have things like app review. So not only are you planning your work, you're having your agents review the work done and then report it. And you're doing this with powerful prompts like the code review prompt, the review prompt. You're then running reproduce bugs, and then things like test backend, test frontend. All right. So for instance, what does review do? Code review current changes, review all stage changes, do a bunch of stuff, and then we're going to output some concrete results. You might also do something like reproduce a bug. This is where we would save a concrete resolution file into app reviews. This becomes really powerful when you start giving your sub agents these abilities. Okay. So we can run something like a review agent, and you can scale this up, and then it will output its review into a specific file. Inside of our application layer here, you'll also notice something. As you start to grow your code base, your agentic layer and your application layer will be growing side by side. We've now split out our application into client and server. At some point, your small code base will grow and it will start to fracture. This is important. We'll look at this in the next grade. But with this application directory structure, we're still able to keep all related code for this product under the same code base. Now, how this operates in Git is important. We'll talk about that in just a moment. Since we have both a front end and back end application, you can start specializing your prompts, right? Test back end, test front end. Here we have a concrete closed loop prompt. I'm being really verbose here with my language inside of these mock prompts. We're following that 3-step workflow from Tactical Agentic Coding Lesson 5, request, validate, resolve. This creates a closed loop where your agent can spin and spin until the job is done. This distinctly marks grade 4. Again, this is a place where engineers fall off and they miss out on using more compute to get the job done. Right? We're starting to split our prompts to focus on specific areas of this code base. Okay, so things are going from really generic and vague, right? Plan, build, to more specific, right? Test our backend, test our front end, review this code how we like to do it, right? And the advantages here are really clear, right? Once you start using closed loop prompts in your code base, your agents start resolving their own work. You can create specialized tasks for your front end, for your back end, for whatever part of your code base, and it's all still on this top layer. Now, we're not going to dive into code-based organization too much here. There are some leverage points of agentic coding that we're not going to re-emphasize here. Here, we're focused on giving our agents the highest capability possible so that they are as autonomous as possible. Now, there are some trade-offs here. Again, things start to get more complex. You need to know how to prompt engineer. This is why our agentic prompt engineering lesson was so important. You must know how to write these prompts properly. Self-correcting agents is a massive, massive win for your agentic layer. Let's move on to grade 5. How does our agentic layer continue progressing? Now, by this point, many engineers have many prompts, many agents, several skills. They've used many different types of MCP servers, and they start scaling their work even further with a key concept we discussed in lesson 3.